araştırmaları olan bir katılımcımız. Bu okulunda yapacağı konuşma mimari koruma ve tarihi taş binaların yenilikçi tekniklerle sismik rehabilitasyonu. Please.
Thanks so much, and I want to thank you all, the organization, and also the municipality of Warsaw for permitting me of being here, and also by my company, Fibonacci. It's a company that envelope systems and solutions for retrofit masonry buildings. So my presentation, as spoken before, is about an architectural conservation and seismic rehabilitation of the historical masonry buildings with innovative techniques, because it's important to conserve buildings, but it's also important to find solution for permitting to the building for his behavior under seismic events and also forces. So, I just want to read some phrases that I've prepared. So, ancient and historical architectures are often subjected to seismic events in many areas of the world, as Mediterranean and Central Asian countries, where some of the most valuable heritage sites exist. The earthquake excitation of these buildings, made with masonry with scarce mechanical properties, cause significant damages in walls. In the last years, innovative materials characterized by high mechanical strength and durability have been developed aimed to guarantee protection, conservation, and safety requirements. The reduction of the seismic vulnerability of this architecture is an important focus for our civil engineering in all seismic countries of the world. This reduction could be obtained thanks to the strengthening, spread or control. First, the bearing wall of the building with various techniques. After describing the innovative techniques focused both to the architectural conservation and seismic rehabilitation, an example of design of structural intervention is furnished. A comparison between the in-plane conformance and unreinforced and spread and reinforced with fiber net restructural system and innovative technique is so to evidence by numerical simulation the effectiveness of this strengthening technique. Normally, as we see in these figures, the unreinforced masonry building represents a significant portion of existing structures in most earthquake-prone regions, which have shown poor performance in past earthquakes, causing heavy damage, structural collapse, and casualties. Normally, the possible causes of damage in ancient reinforced masonry building are these. So the first one is inadequate structural integrity. The second one is the distribution of the resistance elements during the seismic events. Also the scarce strength of material. So the innovative techniques try to improve this strength in order to increase the performances of the building during the earthquakes. So the other cause is inadequate wall-to-floor anchorage. So it's necessary also for the redistribution of the action of seismic events that the floors have to be stiff in order to distribute uniformly the forces on the masonry walls in order to create a seismic-resistant building under seismic actions. And also, it's necessary also for masonry and historical and heritage building to create a box-like behavior, creating an effective link between the masonries, the orthogonal ones, in order to create a sort of box-like behavior. And the last one is the foundation problems. So, normally the first techniques that are used in the past on masonry and also heritage building are steel and nylon cerclage, with the presence of vertical or horizontal tied steel bars. Normally these bars can effectively confine the masonry in order to improve the compression strength and also the stability of the building, creating this concept of closed box behavior. The second one, but it's more strong for the building, is a steel reinforcement mortar coating. But normally, using steel, it can be problems of corrosion, and it consists in the use of welded steel mesh positioned on the surface of the wall connect them on them with passing bar through the masonry in order to realization of 2 cement temper coating. Normally this technique is very stiff, so it's necessary to create a solution and also an innovative technique that cooperate or collaborate with the masonry. It's not a substitution of it, because this one is more stiff, and then the seismic action goes directly to this technique, not going to the masonry, and this is not a good solution. Another old strengthening technique is a grout injection, but it can be used only in masonry with numerous empty spaces, normally called voids. So you can fill these voids with the grout injection in order to control the injection phases and also the effectiveness of this injection. The system that we produce is called FRCM. It's an acronym used in Europe as fiber reinforced cementitious matrix, in which we create a sort of layer of coating reinforced with composite material, the mix of resins and also fibers, in order to create a system or a solution that cooperates with masonry, with poor masonry, in order to increase their characteristics, both in plane and out of plane. So normally these can be innovative techniques because the composite material do not suffer of corrosion actions, so it can be durable during the entire life of the building. Another system that we want to introduce, it's better for the artistic or heritage building that want to maintain the exposed phase of masonry, because this system called reticula, it's a sort of structural repointing of the joints of mortar in order to maintain the exposed face. So you try to insert in the mortar joints these steel strands in order to confine masonry and also to maintain the exposed face. So this intervention was used on Sheikh Suleiman Mosque in Istanbul. Then we tried to create 2 layers of reinforcement in order to maintain the exposed face of the masonry and also to confine the upper part of the building in order to retrofit the building on masonry and also seismic actions. Normally, this system can be used in the mortar joints of the masonry using mortars compatible, also chemical and mechanical, compatible to the substrate of the existent mortar, and also using a plaster with a compressive strength equal to 13 megapascal. And normally we have to cooperate with the designer that needs to ensure uniformity of mechanical behavior, both at the level of horizontal section and at the level of the vertical ones. Another technique that can be used, but it's very difficult to use because it not maintain the exposed face, is the FRP, acronym of fiber reinforced polymer, with high steel strength strips glued to masonry. This can be used for gluing the reinforcement to the masonry surface, and it can be used also for increasing the bearing capacity of structures characterized normally by a low tensile strength, such as those in masonry. So, there is another technique that can be used, and it's called artificial diaphanous. Normally, this technique is a passing through bars that maintain the single layers of masonry united. So it can be, the masonry can be considered as a unicum. Normally, for proving the effectiveness of these techniques, it's necessary to do some experimental tests. I insert just some tests in order to create, and also knowing the properties of masonry, because it's necessary also to know the properties of the existing masonry in order to quantify the effectiveness of the single strengthening techniques. The first one is a diagonal compression test, in order to evaluate the tensile and also the shear capacity of masonry. The second one is a shear compression test, and the third one is a out-of-plane bending test. Normally, defining these experimental campaigns and also proving the effectiveness of the techniques, you can define also the intervention that you want to do. Sorry. Okay. Thanks. So the passage between the first idea of experimental campaign and then the leading of tests and then numerical simulation, you can also expand your numerical models from the single specimen to an entire building in order to create a comparison between the behavior of the unreinforced masonry building, the down curve of capacity, and also the behavior of the reinforced masonry in order to create and also compare the effectiveness of the technique in order also to retrofit the building. So experimental curves and then experimental tests are needed for obtaining the numerical model for the creation for the creation of the entire model of the building, because we have defined the properties of the masonries, and also it's necessary to define the property of masonries with reinforced solutions. So this is just an example, but it's very simple to see. It's an historical building in Italy, and it's used as a school. And normally we have defined the plan, the figures of the shape of the building. So, okay, thanks. We have defined and also created a model from the first part to the numerical simulation in order to define the effectiveness and also the comparison between the unreinforced building and also the reinforced one with the ristruttura, the mortar coating and composite meshes inside in order to define the quality of the intervention. These are the models, but I don't want to explain them. Normally, using these parameters from the experimental test, we can design also the intervention of retrofit, and then to quantify also the effectiveness and also the retrofitting of the buildings with these techniques. No? I'm sorry. But, okay. So, starting from the models of unreinforced masonry, we can create a model to define the effectiveness of this strengthening technique, and we see that for solid brick masonry, for example, we have improved the behavior under seismic actions of 10 times circa. So using a single strengthening technique, we can improve the resistance of the building. So for concluding my speech, normally the experimental studies carried out to evaluate the effectiveness of this strengthening system have shown that there is an improvement of high mechanical strength. It's necessary also to guarantee resistance to corrosion. It's necessary also to have a mortar compatible with lime-based. And it's necessary also to create an intervention that is not invasive and it's reversible. And also, it can be used for the exposed phase of masonries. Normally, the innovative strengthening technique proposed contribute also to significant improvements in terms of out-of-plane bending strength. During a seismic event, the improvement of the out-of-plane behavior of masonry panels is very important because it inhibits the premature fragile collapse of the walls, permitting them to withstand efficiently in their plane the shear capacity. The results of the test are also very precious as a reference to by the numerical procedures, as spoken before, extendable to the wall buildings. These are the other results. And also here, in the last part, there is a sort of references about what I've spoken. I want to conclude just with a video, because in our factory, in our planting factory, we have done an experimental evaluation of the behavior of masonry vaults. Firstly, unreinforced, and then reinforced with our strengthening techniques. It's just for seeing what's the steps from the plan of a single experimental campaign to the quantification of effectiveness of a single strengthening technique. So we have recreated a masonry vault in order to test it on horizontal forces, the forces that can be created under a seismic event. So we have cooperated with University of Trieste, and then we have created the vault, and then we have insert instrumentation in order to define displacement, and also the behavior of the vault loaded horizontally in 8 points. And so this was the behavior of the unreinforced masonry. So it's a fragile rupture. Under a small displacement, it collapsed. Then we have created other vaults with the reinforcement in order to quantify the effectiveness and also the behavior of the different. This is another unreinforced masonry. So we saw that there was a fragile behavior of the vault under horizontal actions. And this is the second test with the reinforcement on the extradoxal part in order to maintain the exposed face of the vault. Then we saw that inserting the reinforcement, there are more cracks, and also there are bigger displacement of the vaults, and that's the effectiveness of the reinforcement. So we create a reinforcement that permits the vault to have large displacement and also to dissipate energy and also create a seismic resistant vault using only a thin layer of mortar and also composite meshes. So you see more cracks on the vault in order to create a dissipative mechanism of the reinforced element. So the vault is damaged, but the increase in terms of strength and also ductility is improved to 15 times. See also the displacements. Because it's a sort of arm vault. So the first one is the not reinforced one, and the other are the reinforced. So there are so many displacement and also ductility behavior of the vault. So this is only for saying that we passed from the experimental tests to the evaluation of the behavior of the entire building using the models that we have defined in our experimental tests. So thank you so much for the
Sayın Dudine teşekkür ediyoruz. Aslında kâgir yapıların depreme karşı güçlendirilmesiyle yenilikçi tekniklerin kullanılması şüphesiz önemli ama bu konuşmada da belirtildiği gibi bunların ne ölçüde geçerli olduğu ya da ne ölçüde mimari korumayla bağdaştığı konusunun herhalde uzun boylu düşünülmesi ve strüktür mühendisleriyle koruma mimarlarının bu konuda çok sıkı bir işbirliği içinde olması herhalde gerekiyor. Şimdi bu oturumun ilk yarısının iki konuşmacısını buraya davet edeceğim. Profesör Marino ve Sayın Dudine, please would you come here for the questions? Konuşmacılarımıza sorularınız varsa bunları yöneltmenizi rica edeceğim. Öncelikle Profesör Marino'nun sunumuyla ilgili sorular var mı? Var mı sorular? Buyurun Zeynep Hoca'ya sorusu. İngilizce sorunu hemen anlasın istersen.
I'd like to ask about the case of mining. You said you are not pleased with the new developments. Aren't there any guidelines for example, to define the materials or the number of stories, the size of the new buildings? How is it chaotic or it doesn't please you?
Of course there are guidelines in all traditional sites. And of course there is from the Ministry of Culture, there is of course, how do you say, a protection. However, in this very faraway land, it is very difficult to have a concise protection because it's very difficult. Those arts are not known anymore, the original way of constructing. It's very difficult. It's not only to give the solution to use stone. So many factors, the stone, the cutting of the stone, between the stone, the materials, they are not cement, the stone are ugly cut, the stone come not from the region. And all those factors give an entirely new image for the buildings. Those are so many details that you must have your masons coming from the special site. And those masons are not anymore in the sites.
Thank you very much.
Başka soru yöneltmek isteyen var mı birinci konuşmacımıza? Yok galiba. Sayın Dudine sorular var mı acaba? Buyurun hocam.
Mehmet Albayrak, öncelikle değerli meslektaşıma sunumundan dolayı teşekkür ediyorum. Bu fiber karbon güçlendirme örneklerinin gerçekliklerine test edildiği bir örneği var mı? Veya yeteri kadar koruma sağlanabildiği düşünüyorum. Teşekkür ederim.
It's very difficult to answer because normally we try to simplify the behavior of a single building during an earthquake. Normally, the simple analysis that we do on a building are a simplification of the real behavior of the building during a earthquake. So we try to find a safety model in order to have more safety using the strengthening technique applied on the building. Normally, we have done so many interventions in Italy, and we reinforced masonry and also heritage and historical buildings in Italy. And then we saw after some earthquakes that the techniques are really effectiveness. But we have safety factors in order to create a safe intervention. So normally we have used our strengthening technique, and then after seismic events we saw that the buildings strengthened with these techniques are not collapsed. So this is our proof. After that, because there's in the design of the building there's a safety necessities of the behavior of the building. So parallel, we saw the behavior of the building under seismic event, it not collapsed. And then we have done other tests in order to evaluate all the behavior of the single elements in order to prevent the mechanism that can be created during an earthquake in the building. So the answer is we have done so many tests in order to evaluate the behavior of the building, because firstly we have to know the behavior of the unreinforced building, and then we can create a design of the intervention. So after these phases we saw in our earthquakes in Italy, because normally we have worked principally in Italy, we saw that after earthquakes the buildings strengthened with our systems are not collapsed. There are so many cracks because I said that the ductility and also the behavior of the building is due to the ductility. So after the earthquake, we saw so many cracks in the buildings, but it is involved in a concept of ductility. So the dissipation of the earthquake energy was done due to the cracks on the systems.